the equation of a circle is essentially the radius of the circle squared equals to x minus a squared, or bracket squared, plus y minus b in bracket squared. R is the radius, and the center of the circle have the coordinates a, b. And you can see it represented here by this circle, with b being the y value and a being the x value of the coordinate, and r, the radius being represented by r. So one thing you can use this for is, for example, if you have the diameter of a circle, you can find out everything you need about the circle. So, for example, here we have a diameter, or a line, which goes from 0, -2 to 0, 2. We can use the midpoint formula to find out where the center of that circle is. So we use the midpoint formula, put in our numbers, and we end up with a midpoint at 0, 0, or origin. Now for the radius, we simply just use the center numbers, and we also use a point which we know is on the circle. So for the radius, we simply just plug in 0 minus 0 squared plus -2 minus 0 squared, which equals to 0 squared plus -2 squared, which equals to 2, meaning that the radius is 2, and the formula for this circle is x minus 0 in bracket squared plus y minus 0 in bracket squared equals to 2 squared. One interesting thing you can use this formula for is to determine if a point is inside or outside the circle. So for example, here you can tell that this point, which is -1, -3, is on the circle, because when you plug in the numbers for the coordinates into our formula, it equals to 4 on both sides, meaning that it's on the circle. For this example here, if you plug in the numbers into our formula, you can see that it does not equal to 4. It gives a number larger than 4, which means that the point is outside the circle. And lastly here, you can see that if you plug in the numbers from the coordinate into the formula, it equals a number smaller than 4, meaning that it is inside the circle. Now for the intersection of a line and a circle. The best way to show this is with an example. So here we have a circle with this formula, x minus 2 in bracket squared plus y minus 3 in bracket squared equals to 2, and a line y equals -x plus 5. So the way you find the intersection of this line and this circle, or any line and circle, is by simply plugging in the line, or the equation for the line, into the equation for the circle. Because as you can see, the y here is just a normal y, while the y here is also a normal y, meaning that y here and y here must be equal to each other if they intersect, meaning that you can simply just plug in this into y into the equation for the circle. Now all you gotta do is just simplify and reduce it. So we expand this bracket here and get this result, and we simplify this over here, then we expand over here, then we simplify and simplify and simplify until we end up with a quadratic equation where x can either be equal to 1 or equal to 3. These two x's are coincidentally, or not so coincidentally, the x values for both intersections of this line. So what you want to do here is you simply put in each of these x's into the line's equation. So you get y equals -5, or -x plus 5 here. You put in the x value for here, so you get y equals -1 plus 5, meaning that y equals to 4, meaning that the coordinates for this intersection point is 1, 4. Then you just do the same thing for the other coordinate, or the other intersection. So you put in 3 here as the x, so you get y equals -3 plus 5, meaning that y is equal to 2, meaning that the coordinate for the other intersection is 3, 2. Next we have another example where in this case there's only going to be one result, because this line only touches the edge of the circle, where in this case you do the same thing again, where you have the equation for the circle and the equation for the line. You put in the y value for the line into the y value of the equation of the circle. So this circle equation becomes x minus 2 in bracket squared plus 6 minus 2 in bracket squared, because here this is 0x, so there's no x to have in this equation. So yeah, you just end up with this. Then you expand both brackets, and then you simplify, and end up with this quadratic equation where x can only be 2, meaning that the one intersection point, you can find that out by putting 2 into our line formula. And since the line formula has 0x, you simply just say y equals to 0 times x plus 6, meaning that y is equal to 6 and that the coordinate for the intersection is 2, 6. Lastly, we have the equation if a line does not intersect with the circle. So here, you do the same thing again. You put in the y value from the line into the y value for the circle. So for this case, this circle equation becomes x minus 4 in brackets squared plus x minus 3 in brackets minus 3 in brackets squared equals to 4. And then, yes, we just simplify and we continue simplifying until we get a quadratic equation. And in this case, if you can tell that this line does not intersect the circle by simply looking at the discriminant of this quadratic equation. You see, the discriminant of a quadratic equation is the square root of b squared plus 4ac. So here we have b 4 as our b. We have a and 1a and 6c, or those are our values. So we simply put it in here. So 4 squared minus 4 times 1 times 6, that equals to 16 minus 24, and that equals to the square root of 8, because all this has a square root. And since you cannot take the square root of a negative number, this entire thing does not work without using imaginary numbers, meaning that this line does not intersect the circle, because you cannot take the square root of a negative number. Lastly, we have the intersection of two circles. So the best way to show this is with another example. So we have two circles here, x minus 2 in brackets squared plus y minus 3 in brackets squared equals to 4, and x minus 4 in brackets squared plus y minus 5 in brackets squared also equals to 4. So first, what we want to do is we want to expand all the brackets in both of these equations. Then we take one of them and we isolate y squared. So we have y squared here on this equal sign, and everything here is there's no y squared on this side. Then you will notice that there's a y squared in both of these equations, meaning that you can take this entire thing equals to y squared, so you can essentially put all this into where y squared was before in this equation here. So you end up with x squared plus 16 minus 8x plus, and all this in brackets, negative x squared plus 4x plus 6y minus 9, end bracket, plus 25 minus 10y equals to 4. Then you simplify. You'll notice that x squared and x squared here, they cancel out, and the rest is simply just normal algebra. And you then want to isolate y once again. So here you take 4x plus 32 minus 4y, because we take the 4 from the right side of the equation, move it here, because we later want to move our y value over here. Then we divide everything by 4, because you'll notice that all of these numbers are divisible by 4, and that's the most simple form you can have of all of these numbers. So you end up with negative x plus 7 minus y equals to 0. And then you isolate y, and you end up with a line which is negative x plus 7 equals to y. And this line equation is then the line that goes between the two intersection points of the two circles, which is why you can use this line to find out what the intersection points are for the two circles. So what you do is you take this line equation and then choose one of the circle equations to put the line equation into, where you replace the y in the circle equation with the line equation. So in this case, I've chosen circle 1 to replace the y in circle 1 with this line's equation. So I end up with x minus 2 bracket squared plus start bracket negative x plus 7 end bracket minus 3 end bracket squared equals to 4. And then we use the same method as before, so we just expand and then simplify. So finally we finally end up with a quadratic equation here. So you have x squared plus 8 minus 6x equals to 0. Then we find the common factors. So in this case, the common factors are -4 and -2. And you can tell that because this here is positive while this is negative. And then we see that x can either be 4 or 2. And then we do the same thing again. We put in these x's into our line formula. So we end up with y equals to 5 and y equals to 3. So we end up with the points 2, 5 and 4, 3, which are our two intersection points. Now, if you want to do the same thing, but with two circles where only the edges touch, there's only one intersection point, you do essentially the same thing. As you can see here, you do the same thing all the way down as you do over here. The only difference comes down here when you're doing the quadratic equation. So as you can see, here we ended up with x squared plus 9 minus 6x equals to 0. Here, there's the common factor is just -3, meaning that x can only be equal to -3. And then when you put x can only be equal to 3, so when you put 3 into our line equation, we get the line equation we got up here from doing the rest of this. We end up with -3 plus 6 equals to y, meaning that y equals to 3, meaning that our intersection point of these two circles are 3, 3. Now, lastly, we have two circles which do not intersect, so we essentially do the exact same thing as we did before, where we take we expand both equations and then we isolate y squared in one of them and replace y squared in the other with everything here. And then we essentially just simplify and end up with isolating y. So in this case, we get the line equation 33/6 minus 4/6x equals to y, because this is how it ended. Next, we do the same thing before, where we plug in the line equation into one of the circle equations. In this case, we chose circle 1 circle equation. So we get x minus 2 squared plus 4/6x minus 33/6 in brackets minus 2 in brackets squared equals to 2. Then we simplify and we end up with this quadratic equation called 1 and 4/6x squared plus 34.25, or 34 and 1/4, minus 11 and 1/3 x equals to 2. Next, to check if the two circles intersect, we simply use the discriminant for the quadratic equation. So we plug in our values. So our b value is going to be 11 and 1/3, and our a value is going to be 1 and 4/6, and our c value is going to be 34 and 1/4. And if you simplify all this, we end up with 73 and 2/9, or negative 73 and 2/9. And we need to take the square root of that, which we again can't do because it's a negative number, and that in all means that these two circles do not intersect because there is no valid x to be had.